Okay, this will be the last recording for reviewing the quadratic formula packet. We are going to cover numbers 28 through 35 in this video. First off, we're going to solve using the quadratic formula in numbers 28 through 31, and then we're going to talk about the methods for number 32 through 35. So in number 28, you want the quadratic formula, which right away, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's very helpful to identify a, b, and c. So a is 1, b is negative 5, and c is negative 24. So I have negative 5 plus or minus the square root of negative 5 squared minus 4 times a times c, all over 2 times, 2 times a, which is just basically 2. Simplifying this would give me 5 plus or minus the square root of 25 plus 96, all over 2. And that would give me 25 plus 96 is 121, and the square root of 121 is 11. So I have two ways I can do this. 5 plus 11 divided by 2. 5 plus 11 is 16. 16 divided by 2 is 8. 5 minus 11 is negative 6. Negative 6 divided by 2 is negative 3. So therefore, my two solutions for this are 8 or negative 3. For number 29, a equals 1, b equals negative 4, and c equals positive 5. So, negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Now for this one, you're actually going to get a negative radical, which is negative 4, all over 2. So the way I simplify that negative radical, as we talked about earlier, is to take the square root of 4, which is 2, and the negative part becomes an I, all over 2. Now if you want to simplify this even further, 4 divided by 2 is 2. 2 divided by 2 is 1, so 2 plus I. And same thing, but now it's going to be 2 minus I. I'm going to turn the page now to numbers 30 and 31. For number 30, you have to first get this equal to 0, which means to add 8x and subtract 3 from both sides. So that gives you 4x squared plus 8x minus 3 equals 0. A equals 4, b equals 8, c equals negative 3. Now I'm going to put it in the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. That will simplify because negative 8 plus or minus the square root of all of this will simplify to 0. So the square root of 0 is 0, and when my discriminant is 0, that means I'm only going to have one solution. Okay, let me back up for a minute. I was looking at the wrong problem. This is not 0. Your discriminant here for number 30 is going to be 112. So you're actually taking the square root of 112. Several ways of doing this. You do negative 8 plus the square root of 112 divided by 8, and negative 8 minus the square root of 112 divided by 8. So you will need to do both of those solutions. If you would like to simplify the radical, you can do that, or you can just get two decimal approximations, which in this case will be either negative 2.32 or positive negative 0.32. Now you can verify all of these by graphing. If you graph all of these quadratics, whether you are factoring or taking the quadratic, checking them on your graphing calculator to make sure that it intersects the x-axis is always an excellent way to check, and you should be checking all of them using that method of graphing. For number 31, you first have to subtract 2. 2x squared minus 4x minus 2 equals 0. In this one, there is a GCF you can take out. You really don't have to. You can evaluate it using A, B, and C because it will simplify in the end. So therefore, I'm just going to go ahead and use them the way they are. So I'm going to take negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. For this one, you will have 4 plus or minus the square root of 32 over 4. So again, doing the same thing you just did in the last one, you can simplify that radical of 32 and leave your answer in radical form, or you can get decimal approximations. Either way, when you multiply them out, you will get two decimal approximations of 2.41 and negative 0.41. Okay? If you'd like to pause it, you can do so, but I will be moving on to the last four. In number 32, again, now we can solve by any method. I have to subtract 12x, so therefore that 12x actually becomes my middle term because it has that x value there. And this one, if I solve using the quadratic formula, I would have a equals 4, b equals negative 12, and c equals 9. So therefore, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a would give you 12 plus or minus the square root of 0 over 8. So that basically just leaves you with the answer of 12. Because that 0 is gone, it's really just 12 over 8, meaning you have one solution. If you simplify the fraction of 12 over 8, you get 3 over 2, and there is no other solution for that one. Number 33. This one is actually going to be an imaginary. You don't know that starting out right away unless you evaluate the discriminant here. So a, b, and c, and negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. When you evaluate underneath the radical, which is the discriminant, you would have 6 plus or minus the square root of negative 4 over 4. That would turn into 6 plus or minus 2i. The square root of 4 is 2, and the negative becomes the I. And now you can simplify, or just leave your answer as 6 plus or minus 2i over 4. So 1 is 6 plus 2i over 4. If you simplified that, that would be 3 plus I over 2. Same thing here. If you want to do 6 minus 2i over 4, to simplify would be 3 minus I over 2. Okay, and for number 34 and 35, our last two problems, for number 34, this one will factor. You should recognize, or can recognize, that this is actually a perfect square. X plus 4 times x plus 4. So therefore, you only have one solution. X plus 4 equals 0, minus 4 minus 4, x equals negative 4. So your solutions are negative 4, and the other one does not matter. 35 is a difference of squares because you subtract 9, so you have 4x squared minus 9 equals 0. So you have 2x plus 9 and 2x minus 9. Solving both of those equations, 2x plus 9 equals 0. Subtract 9 from both sides, 2x equals negative 9. Divide both sides by 2, so x equals negative 9 over 2. Over here, 2x minus 9 equals 0. Add 9. 2x equals 9, divide by 2, and x equals positive 9 over 2. This concludes the review packet for quadratic equations. Study hard. If you have questions, ask your math teacher.